Hi, I'm Albert, and I'm making the Ice Climber game for the Nintendo Entertainment System from scratch. Welcome to my devlog. This video is going to be all about game loops. If there is one programming pattern a video game couldn't live without, this is it. Almost every game has one. No two are exactly alike. In my journey to remake the Ice Climber game, I have obviously had to implement a game loop. If the game loop programming pattern is unfamiliar to you, don't worry. I will take a brief pause to explain what this pattern entails, and then I will delve into more technical details. A game loop consists of a loop that runs continuously while a game session is active. Each turn of the loop, it processes user input without blocking, updates the game state, and renders the game. Also, it tracks the passage of time to control the rate of gameplay. The code for a game loop is actually pretty straightforward. The process input function captures user input such as reading the keyboard, mouse, or any other device used to control the game. The update function updates the game state, including calculating object positions, detecting collisions, or applying artificial intelligence. The render function creates and displays the current frame. The problem with it is you have no control over how fast the game runs. On a fast machine, that loop will spin so fast, users won't be able to see what's going on. On a slow machine, the game will crawl. In this context, the rate at which this loop runs is crucial for the game's performance. Therefore, it's necessary to make pauses to ensure the game doesn't run too fast. The sleep function makes sure the game doesn't run too fast if it processes a frame quickly. That said, it's essential to ensure that the game plays at a consistent rate on different hardware. If you want to follow the progress and support me, I really appreciate if you give me a like and a subscribe. Thanks so much. Okay, after this brief explanation, I will describe the architecture I have used to implement my game loop. Video games fall into the category of software applications that combine intensive real-time graphics and heavy calculations of object states. This means the CPU is used to compute the game logic, such as positions, collisions, and object states, as well as running artificial intelligence algorithms to simulate autonomous behaviors. Meanwhile, the GPU is used to render and display the game objects given its current status. In my view, these two major tasks can be performed separately and concurrently in two independent game loops. One game loop for the update function, responsible for game logic, and another game loop for the render function, responsible for rendering and displaying frames in real time. Both loops coexist using a thread-safe double buffer to share the sprite positions that should be redrawn. You might wonder what advantage this architecture offers compared to the sequential execution of the basic game loop pattern. It's very simple, and I will explain it with a practical use case. Let's suppose I add support to play in multiplayer mode over the internet. The game must ensure that the different users play under equal conditions. That is, if a user plays with a very slow computer, then the game loop speed will be lower than that of other users with much faster computers. This means that the character controlled by this user will perform actions like walking, jumping, or hitting more slowly compared to the other users, and therefore the gaming experience is highly compromised. Using this concurrent approach, the loop responsible for rendering frames will not block the code responsible for computing the game logic. In fact, a user with a very slow computer could configure the game to use a lower number of frames per second, thus significantly increasing performance at the expense of the game visual smoothness. If both game loops cycles quickly, then the frames per second is high and the game moves smoothly and quickly. Okay, that's going to wrap up this second episode. The project is gaining momentum, and I assure you that I have many interesting things to implement and explain. I look forward to showing you my progress next time. Thank you for watching.